Today we're going to look a little bit deeper into conditions, if, elif, and else. Hopefully you've already looked at the first learning exercise, the reading worksheet, to get a little bit of an understanding of what if conditions are. Now we're going to dive in deeper into some cases that you might not see in the semester, but you could. So we're going to more fully develop all the theory related to if statements. So recall we're following along with the 7 basics of computer programming. We've looked at variables, math and logic, input and output, loops, and functions, just a little bit with using functions, and now we're going to focus on conditionals. So conditions evaluate to true or false, and you might recognize these as the 2 values of the Boolean type, which I promised we would talk more about. Now we're talking about it. An example condition is up in the top right where we have if num is less than 0. That's an example if condition. We can use comparators to compare values such as less than, greater than, less than or equal to, greater than or equal to, not equal to, or equal to. Notice that equal to has 2 equal signs. There's a reason for that. Have we been using the equal sign already in our programming? Why, yes, we have in assignments. Also, notice there's an exclamation point equals. Well, an exclamation point often means not in a programming context. Okay, so let's take a look at these different what are called relational operators, the syntax of the conditions we can put. And so we've got our less than or equal to, greater than, equals, and not equals, as we just explained on the previous slide. If you want, you can test these using the Python interpreter or your own Python programs. Now, we've got our comparators. Let's say we want to put our comparators together. What if we want a value, let's say we are looking for a range in the temperature. We want the temperature to be greater than 32 but less than 98. Well, the way we can do that is we can combine Boolean expressions with and, or, and not. So what does that look like? Well, if you say something is not, that makes it the opposite. So if let's say we've got some condition called A, and we are trying to evaluate if it's true or false, If the condition is true and we say not the condition, then it becomes false. Likewise, if the condition is false, then it becomes true. Similarly, for and or, except now to explain and or, I need 2 conditions, an A condition and a B condition. The conditions can be any types of comparators or really any Boolean expression. You can check to see if a value is equal to something, you can see if it's less than or greater than, or any other combination. So just like arithmetic expressions, these conditions can be combined. In the bottom right, to explain and or, I'm assuming some nebulous condition called A or B. These are just placeholders. So if we've got 2 conditions, A and B, and they're both true, then in addition, A and B is true, and A or B is also true. You can use your intuitive ideas of and or in this. If you want to say a statement, a conditional expression to yourself in your head, you can kind of see if it should be true all the time or not. At the bottom, which is a little bit cut off here, my apologies, we have false and false. If the conditions are both false, then A and B is false and A or B is false. The only difference is when only one of the conditions is true. When only one of the conditions is true, A and B will not be true. For A and B to be true, both A and B must be true, just like in the first line here. But in this case, if A or B is true, if either one of them is true, then A or B is true. We've already hopefully looked at some basic examples of the if statement. Let's formalize its syntax. We have if some condition, colon, and then anything we want to happen if that condition is true is then indented underneath that if statement. And so keep in mind we're using indentation here. Then maybe we have another condition that we want to have true. Then we use an elif. Elif conditions are only evaluated if all of the prior conditions were false. So as soon as we find a true condition, then that's Those are the statements, the indented statements we're going to execute. Finally, if none of the conditions are true, we fall down to this else. Now, for an if statement, at minimum, we need an if condition colon and then some indented statements. We don't need an elif, we don't need an else. These are optional. So we could have 0 or more elifs. We could have a gazillion elifs. We could have a lot of them. We can only have 0 or 1 else though. So a very common mistake is the assignment operator versus the equality operator. So very often when students are first learning to program and learning to work with assignment and equality, they will confuse this. So for example, if remainder equals 0, yeah, this is a syntax error. And fortunately for you, Python will actually catch this error. There's many languages that will allow you to make an assignment in an if, even though it's usually not what the programmer wants to have happen. So Python is a good learning tool in that it'll catch these syntax mistakes when they're made. So remember, when you're doing equality in an if condition or an elif, you always do 2 equal signs, not 1. Now this is the example that hopefully you've looked at for reading ifs. And if you haven't yet, I highly recommend you take a look at this example. And one final question. Now that we're starting to build bigger programs, we can ask questions about solutions and which ones are more or less efficient. So for example, here we have 2 different solutions to the same problem. We want to determine if a number is even or odd. Solution A is going to consist of 2 ifs, not an if and an else, but 2 ifs. If remainder equals 0 and if remainder equals 1. Then we're printing out whether the remainder is even or odd. In solution B, we're saying if remainder equals 0, print even, otherwise print odd. So my question to you is this: which one is more efficient? Take a moment and think about it. If you said solution B is more efficient, you would be right. Now why? Well, if we look at solution A, they're very similar, but if we look at solution A, we are comparing 2 things. Remainder equals 0 and the remainder equals 1. But we don't have to do the second comparison. Once we know that the remainder is 0 or is not 0, if this is false, we immediately know, as in solution B, that it's an odd number. So we can save ourselves a little bit of efficiency, a little bit of time by not doing the second comparison. Now you might think, oh gosh, Dr. Hill, this is such a little tiny minor thing. Well, when you take these little comparisons and you save them, just as saving a penny each day will get you to $3.65 at the end of the year, saving on this efficiency, when you work at a lot of data, when you work with a lot of data, it will actually make significant savings. It can make the difference with large data sets from being able to solve the problem in a reasonable amount of time, a time that you're worth waiting, that you'll wait on, versus not solving it at all. For example, I remember I rewrote a program. I had a program that took 3 days to run. It took me 3 days, so 24 hours times 3. And I rewrote it, taking care of things like this, efficiency errors, and I got it down to 18 hours. I've had experiments that have taken 3 months to run. So when you start working with bigger programs, not the ones we're working with in this class, but in the future, if you wanted to write bigger programs working with lots of data, suddenly these details of efficiency become very important. Okay, if you'd like more information about conditions, please refer back to the slides.